Hi everyone, quick little project update regarding the BMW i3 inverter board. And as you can see, it's turning a motor, but unfortunately it's not using the VESC firmware to do that. It's using a test program, which is a totally open loop variable frequency drive, where the current and frequency are manually controlled. There's no feedback whatsoever. It just generates 3 sine waves 120 degrees out of phase, and their frequency and amplitude can be controlled. So if you turn these the wrong way, things can get quite violent and this motor would start jumping about and the power supply would cut out. And that's why I'm running this on a power supply, so that if anything goes wrong I don't blow the fuse on the bike battery down there. So yeah, as you can see, it's turning smoothly and quietly, and it's drawing no current, which seems to register on this ammeter here, so that's really good. The whole thing's stone cold, which is brilliant. It shows that the power stage is working properly. Now I suspect the reason why VESC is failing the motor detection is because there's just very little voltage swing on the current and voltage sensing signals, because the current sensors in this, I think, detect up to 800 amps, and I'm running far less than that through it, so that translates to very little voltage swing on the output of this, which is really just, it's barely above the noise floor of the signal, so it's hardly been picked up. Same with the voltage as well. Normally with this thing you'd probably be getting like maybe a couple of 100 volts coming in through the voltage sensing wires, but just now it's probably far less than that, so it's just generating hardly any voltage swing for the microcontroller to pick up. So I reckon what I'll have to do is add amplifiers or switchable voltage dividers to the signals in order to give you a more reduced range. I would reduce the current and voltage which you could put through it, but I would give better measurement accuracy and it would hopefully be able to pass the detection. So I'd maybe have to have configurations where you could set, if you want to run this inverter on say 100 volts maximum, 200, or the full 390 volts, just so that the amplifiers and everything are going to work properly. The other issue is noise. I've still to figure that out, because these inverters don't have snubbers on them. Any ringing from the IGBTs is just going to be everywhere, which I think on a well-designed board or well-designed control board isn't a problem, but I've still to sort that out. So I reckon what I'm going to have to do is put a lot of extra filtering on the current and voltage signals, and that will solve the problem. So I need to redesign this board. The resolver driver, when I was running the VESC firmware, I don't know if I've damaged this or not, but I'm no longer getting the 10 kilohertz tone which comes out of this to drive the amplifier. It gives out a 10 kilohertz sine wave which goes to this amplifier, which drives the exciter coil and the resolver, but that signal's not present anymore. I think it's maybe a VESC issue, because I enabled that, and I think after I enabled it in code it stopped working, but I've not actually tested it just with this test firmware, which is doing nothing else apart from responding to these settings here. So I'll do some experiments on the new board. These will be in the form of modules. You could just put in a different module. I'll be able to experiment with different like voltage sensing modules, the resolver driver modules as well. They could be swapped out, as well as the resolver amplifier. I think I'll go for a class D option next time. Maybe we could try that out, and that should hopefully work better, because for a 10 kilohertz signal a class D amplifier should be totally fine. But yeah, I'm making good progress, but I'm at a bit of a crossroads just now with VESC, because quite often in the VESC Discord I find that my messages just get buried in the chatter and I don't get responses, and there was one member that they weren't being particularly nice to because maybe English wasn't his first language and he wasn't too clear in what he was asking, and I didn't really like that. And yeah, it's just kind of annoying being ignored all the time. So this might eventually not even be VESC based at all. If ChatGPT keeps going the way it's going, this is going to probably end up as something totally different altogether. It may be something much more basic than VESC, but it'll do what I want it to do. And it'll have a very simple companion application where you could just plug it into a computer and do your settings, and that would be it. But I've no idea if that's something that myself or ChatGPT is capable of doing. So that's a road that I'm quite close to going down, because you think in a passionate community of hardware developers they would actually be keen to respond to you and try and work things out with you, but this doesn't appear to be the case. I've found it's like I start a good conversation with them and we get somewhere, and then I reply with what information they've asked for, and then I just don't hear anything back. So yeah, I think I might be leaving it with VESC, so we'll see.